MEERA Simulation. Construct AI Physics Hybrid Framework. Decline curve analysis is a means of predicting future oil well or gas well production based on past production history. Choose a dataset for which you want to perform decline curve analysis. Choose the rate variable of your interest. For example, I want to perform analysis on the oil production rate. I leave the last point setting in the default values. Hitting the Apply to All Wells button, the decline curve analysis is performed on all the wells at once. The values of optimized variables are updated. Alternatively, you can perform DCA in a well-by-well manner. Select a well and push the Decline Curve Analysis button in the Tree toolbar. The analysis is performed automatically within a start and end date detected by the algorithm. Let's perform some modifications on the automatic algorithm. You can exclude a parameter from the auto adjustment algorithm and set its value manually. Open the Optimize Variables combo box and remove the checkbox of variables which you want to edit manually. The fitted decline curve is lively updated according to the entered value. Let's try another well. A new tab is opened and the previous tab is kept. I want to enter QI manually for this well. In addition, for the well 13.1, the B and DI are manually entered. In each calculation, the R-square and MSE are updated. The mean squared error, or MSE, of an estimator measures the average of the squares of the errors, that is, the average squared difference between the estimated values and the actual value. R-squared is a statistical measure of how close the data are to the fitted regression line. You can also change the start and end date of the analysis. The decline analysis is changed lively after editing the start and end date. You can enter the date by either typing or selecting from the calendar. All facilities of the chart, like zoom, pan and move, is available in decline curve also. Now we're going to see all the modifications in a single spreadsheet for all existing wells. You can see all the optimized variables and their values for both manual and automated algorithm in this spreadsheet. You can export the result of the analysis to a desired file format. MEERA Simulation can export file to formats of XLSX, XLS, HTML, PDF and TXT files. I select the Excel file and browse the file directory for performing export. Feature selection is used to limit the number of input parameters in machine learning algorithms. Select a dataset first and hit the feature selection button placed in the AI data pane toolbar. The algorithm computes a correlation matrix and correlation coefficients are visualized as matrix arrays. You can maximize the correlation matrix to have full screen view. The user can choose between full variables, which uses all of the variables in wells, or reduced variables, which reduces the variables in wells so that each variable has only a single value per well. It's easier for the user to use the right panel instead of the correlation matrix to analyze the results. I selected the oil injection rate, but since we don't have the oil injection rate in the model, all correlation coefficients are 0. Let's choose another variable which has a correlation with others. Also, note that the values in this panel will be automatically sorted by their absolute value. I think the completion average value of the Z direction permeability is a good choice for displaying the correlation coefficients. Let's try the coefficients for completion height as another variable. There is a touch view option in all spreadsheets which will increase the height of each cell. The most useful reduction algorithm for rate variables is DCA, or decline curve analysis. Push the set all to perform the algorithm for all variables. This algorithm produces 3 DCA values for each rate variable and computes correlation matrices for them. MEERA Simulation has a unique ability to use both machine learning and numerical simulation simultaneously. This ability makes it able to generate more precise results. Creating a dataset from simulation would be performed simply by using the related option. The model will be simulated by the simulator, and a dataset is created from the simulation process. Having created the dataset, the user can then merge it with static data. Set the name of dataset in the Merge Tool tab and select desired interpolation type to create the reliable dataset for performing neural network analysis. Then create the related training and forecast cases and run them. Create the training dataset and select all required inputs and targets for the desired wells. For example, the block saturations, pressure difference, and well index for each layer of model, along with well position, can be selected as input variables, and select oil production rate as the target variable. Let's create a forecast case. The target case should be selected, and the end date of forecast must be entered. You do not need to change the input options of the inputs. Leave them as the default value and save the created case. Now we're ready to run the created cases. Select each case or multi-cases and hit the console's Start Simulation button. During simulating the cases, required messages are displayed in the console. Once the run finishes, we can visualize the results. By having the result viewer, the user can easily compare the results of the conventional and simulated cases with each other. At first, I selected the pure neural network results in which the raw data points could not be trained correctly. Then I want to compare the result of the created dataset form simulation with that one for the same well. Note that for a good comparison between results, you should fix the axis of minimum and maximum values. You can see here the case which is linked by simulation, that is, created from the dataset form simulation, has better results, and all of the raw data can be trained more precisely.